Kong Connect Enterprise session. So yeah, my name is Claudio Coviva and I'm software architect here at Kong. So here's our agenda for today. For the first topic, I'll be talking about Kong API Gateway and typical policies we implement in these layer, including rate limiting, log processing, authentication, caching, and so on. The second topic, we will explore how to, first of all, how to expose an existing Kafka platform, and the second of all, to control these the platform consumption using the same policies I have listed before. The demo session will cover 2 use cases. The first one, I'm going to show how Kong can translate a regular REST request into a Kafka message and post this message to an existing Kafka topic you have already in place in your Kafka platform. The second use case, I will show how Kong platform, the Kafka platform can be used as an external log processing infrastructure. So in this sense, Kong will be externalizing all the information regarding the requests that have been processed by the gateway, of course, and then externalizing all this to the Kafka platform. All right, so to get it started, it's very important to consider that companies in general are in this journey to decentralization. That is, they got started developing their applications using the usual monolith pattern, and then for several reasons, for instance, they want to have a faster time to market, they want to reduce their development costs. Now these customers are looking for new distributed environments to develop their new applications and maybe migrate the current ones to these new distributed environments. So we can analyze this scenario from 2 different perspectives. Number one, the patterns, the architecture patterns. So not just the monolith pattern again, but also services, microservices, service mesh architecture pattern. That will be the natural evolution of your microservice project. Serverless, as a matter of fact, any emergent pattern we can have along the way. And the second perspective will be the platforms themselves. I mean, when we're coming to these distributed environments, companies would like to have support for all these main runtimes available today. Not just the regular, for instance, Linux operating system-based deployment environments, but also virtual machines, and then containers, Docker containers, and then orchestrators like Kubernetes, and so on. As a matter of fact, all these runtimes at the same time should be supported. So in a sense that your application will be running in a highly distributed and hybrid environment at the same time. Having all these in mind, Kong has designed a service connectivity platform, which is the Kong Connect Enterprise product, to accelerate this journey to decentralization. So what is Kong Connect? Kong Connect Enterprise, to put it simply, is a cloud connectivity fabric. In other words, Connect is a cloud-native connectivity platform that, first of all, has been hosted as a service, and second of all, it can take care of all connectivity use cases across any environment, including VMs, Kubernetes, and so on, for both gateway and mesh, for both north and south, east-west traffics. So as you can see in this slide, Kong Connect is an end-to-end solution and has several components. The first one, and by the way, this is our focus for today, is the Kong Gateway, which is the classic API gateway responsible for the north-south traffic to protect your services. Second component is Kong Mesh, our service mesh implementation, responsible for the service-to-service communication control or microservice to microservice communication, if you will. Service Hub, that will be the third component. I would say that's the heart of Connect. Service Hub, as a matter of fact, that's the repository where the admins and designers use to store all the service definitions along with the policies, documentation, routes, and so on and so forth. And then again, the developers can go to the Service Hub in order to search, discover, reuse these services in their development processes. The next component is Kong Developer Portal, providing a single source of truth for all developers, including internal and external developers. And then the developers can go to these local Kong Dev Portal to locate, access, and then not just to check the API documentation, but as a matter of fact, they can try the APIs out with the specific sandboxes and playgrounds. The next one will be Vitals. Vitals is responsible for monitoring the gateway health and performance, providing KPIs regarding latency times, caching, API consumption data, all these in real time. Last but not least, we got Kong Immunity. Kong Immunity is a machine learned based engine looking for API consumption anomalies in order to improve security, mitigate breaches, and so on. So now this diagram over here shows you a typical API gateway deployment. We call this the hybrid cloud API gateway deployment. So a couple of comments on this. Number one, as you can see, the API gateway has been split in two sublayers. The first one, the blue one, is what we call the control plane. That's the component the admins go in order to create new APIs and policies. And then the control plane is responsible for publishing, broadcasting these APIs and policies across the multiple data planes you got in our API gateway cluster deployment. And by the way, these data planes, these are the second sublayer of our API gateway cluster. So in this sense, you're going to have multiple data planes to secure and protect your microservices whenever they're running right now. So for instance, we're going to have microservices running, regular Linux on-premise deployments, so that will be reasonable to have data planes to protect them. At the same time, you're going to have microservices running Kubernetes, for instance, Azure Kubernetes cluster, Azure Kubernetes Service cluster, and then again, that will be reasonable to have other data plane instances to take care of these and protecting these microservices running inside this Kubernetes cluster. Another perspective, very, very important perspective, provided by Kong Connect Enterprise is the extensibility. So Connect Enterprise provided an extensive list of extensions. We call these extensions plugins. So each one of these plugins is responsible for a specific functionality. For instance, from the authentication perspective, we provide lots of plugins, each one of them responsible for implementing this authentication mechanism. Like, for instance, base authentication, JWT, mutual TLS, very, very important authentication and security mechanism, OAuth/OpenID Connect standards in order to implement these specific authentication processes, integration with Vault from HashiCorp, and so on. And then from the transformation perspective, the traffic control perspective, we provide plugins to deal with Canary release, if you will, to implement Canary at the API gateway layer. And then we provide plugins to implement integration with the existing GraphQL servers, plugins to implement caching internally or consuming external Redis infrastructures, and then plugins to implement rate limiting with both fixed and sliding window algorithms and so on. Then from the transformation perspective, we provide plugins to transform requests before sending, routing them to the upstreams, and similarly to transform their responses before getting back to the consumers. And then, as you can see here, we provide a specific Kafka upstream plugin. That's the one responsible for translating requests into Kafka messages and post them to existing Kafka topics you got in your Kafka platform. And then we provide serverless plugins in order to integrate existing serverless infrastructures like AWS Lambda, Microsoft Azure Functions, and so on. Finally, we provide extensive list of log plugins to implement all sorts of logging processing, like file-based log. And then again, you can see the second Kafka plugin. This plugin is a Kafka log plugin. So in this sense, we're going to use the Kafka infrastructure as our external log processing infrastructure. So in this sense, again, the gateway will be externalizing all the requests to this Kafka platform. And then you can take advantage of the Kafka capabilities to run queries, reports, dashboards, and so on. And then other than this, we provide still for log processing, we provide specific plugins to integrate with the Prometheus, Datadog, Zipkin for tracing, and so on and so forth. Now, let's talk about a little bit about the API gateway and Kafka event streaming platform integration. So consider this very simple diagram here. So as you can see, there are multiple runtimes consuming and producing messages to and from your Kafka platform. And then we are assuming, considering this, the whole infrastructure is totally confined and being consumed by internal systems only. So what happens if you want to expose your Kafka platform to new and external application services? That will be one of the main reasons why to include the API gateway in your architecture. And then again, the API gateway will be responsible not just to expose your Kafka infrastructure, but again, will be responsible for applying policies and protect the Kafka platform consumption. So a couple of comments here. On your left, as you can see, we can apply some specific API gateway policies, again, including rate limiting, caching, log processing, and so on. On your right, again, highly recommended to have this strong relationship with the external identity provider in order to implement these OpenID Connect based authentication processes. And then the gateway will be receiving not just regular REST-based requests, but also gRPC, WebSockets requests, and so on. And then the gateway, more precisely, the Kafka upstream plugin injected inside of it will be responsible for translating these requests into a Kafka message, and then again, post these messages to your existing topics running inside your Kafka platform. The final comment on this, after translating the request into Kafka messages, the post will be done using MTLS encrypted tunnel. So kind of a secure tunnel with the API gateway, between the API gateway and the Kafka platform. Another very important use case, again, is using the Kafka platform as the external log processing infrastructure. So then again, the API gateway will be responsible for receiving the requests and processing the requests. Some of them will be routed, will be translated and routed to the Kafka platform. Some other requests will be routed to the usual upstreams. But the thing is, besides all this, the API gateway will be, again, externalize all the requests that have been processed by it to your Kafka platform, maybe to a specific topic you got already in place. And then, of course, you can take advantage of these Confluent control centers and so forth to, first of all, to check the requests and then run the queries and so on and so forth. Last, I like to talk a little bit about the Ceph Mesh integration with the Kafka event streaming platform. So Kong Connect Enterprise provides another component, which is the Kong Mesh, our Ceph Mesh implementation. And then out of the box, Ceph Mesh supports the Kafka protocol. So in this sense, your Kafka protocol is not going to coexist with Ceph Mesh, but more than that, will be part of your Ceph Mesh, meaning that the Ceph Mesh SARD card will be injected in your Kafka broker as well, just like any other microservices you got running inside your Ceph Mesh implementation. And then to protect the whole cluster, assuming that you have deployed your Ceph Mesh in a Kubernetes cluster, we're going to protect the whole Ceph Mesh with the other Kong Enterprise component, which is Kong for Kubernetes English Controller. And then, of course, displaying the English Controller role, protecting the Ceph Mesh, and then applying, again, specific policies to make sure that the consumer is reliable, requesting credentials for authentication, applying rate limiting policies, and so on and so forth. So before showing you the two use cases for my demo session here, I'd like to describe a little bit more what I got in my demo environment. So first of all, here's Kong Manager, which is the Kong Connect Enterprise control plane admin GUI. Yes, that's the GUI admins use in order to create new APIs and then new policies and so on. And then if we go inside this workspace here, first of all, you can see that there are some activities in my API gateway here. As a matter of fact, I got a script running in the background, sending requests to the API gateway. That's why we're seeing some results in here. And then again, you can see that I have already created 2 routes in my gateway, one for each use case. So the first one is the Kafka upstream route. And then this route is defining a path, this slash Kafka upstream. And then if you click on it, you're going to see there's a specific Kafka upstream plugin enabled to it. And then if we check the plugin settings, you're going to see there's specific Kafka platform settings in there. For instance, this port over here, 9093, is saying that, you know, I'm going to use the encrypted port, the MTLS encrypted tunnel port, 9093. And then down here, you can see I'm going to use this test topic already in place to send these translated requests to the Kafka platform. And then I got the second route over here, the Kafka log route, exposing this Kafka log path. And then again, similarly, I got the Kafka log plugin enabled to it. Again, my script running background is sending requests exactly to this route right here. And then if we check the Kafka log plugin, you're going to see similar Kafka settings. This time I'm using the second port, not encrypted tunnel, just because I want it. And then I'm going to post the request to this other topic over here, it's test log topic. And then if you go to the Confluent Control Center, we can see both topics. The test log, as a matter of fact, already receiving the requests coming from the process requests coming from the gateway. And then you can see not just requests, but you can pick one of those and then check all the headers one by one for each one of these requests. So kind of, you know, the headers related to latency, service, requests, the client IP, of course, the response headers, and so on. And then if you go to, again, inside my control center, you can see the second topic here, the test topic, this topic will be receiving the translated requests processed by the API gateway, more precisely the Kafka upstream plugin. So now let's send some requests to this route over here, and then see the translation to Kafka messages and see these messages being posted to this topic over here. In order to send requests to the API gateway, I'm going to use Insomnia. Insomnia is our API spec editor. So before sending requests to the API gateway, I'd like to talk a little bit about the Insomnia from the API spec perspective. So if you, for instance, if you open this spec over here, we're going to see in our left, it's Open API base spec. And then on my right, we're going to see the visual representation of the API spec. As a matter of fact, not just the representation, but as a matter of fact, the designers can try the API out, sending specific parameters to it and see it and check the responses and so on. Another capability is the Git-based repository integration. So for instance, just an example here, my Insomnia is connected, is using Code Commit, which is the AWS Git-based repository, in order to store all the API specs. So in this sense, all the designers will be working with exactly the same API repository, every API spec repository. And then there's a linting process. So every time I got a syntax error, I'm going to be warned, receive some alerts, and then I'll be able to correct them. So now let's send some requests to the API gateway and see the transformation now. So let's use this dashboard over here. And then I have previously created this request over here. So what happens if I click on send, I'm going to receive this message sent message. And then if we go back to our Kafka topic, more precisely the test Kafka topic, we're going to see our brand new message over here. Again, translated from the REST request the API gateway received. As a matter of fact, if we send another request to it, for instance, injecting a specific header just for fun, and send it to the API gateway again, you are supposed to see a new message in there, this time with the headers injected inside of it. So let's wait a little bit more. Let's send another one just in case. Yeah, there you go. So now the second message translated from the REST request, and now we can see the two headers in there injected inside my message. So so far so good. I can send as many requests as I want to the API gateway, and then having this message posted to my Kafka topic is good, but not that good. I mean, again, I can send as many requests as I want to the API gateway. It's good, but you know, that would be better if I had some policies preventing me to send requests as many times as I want. So now let's go back to Kong Manager and then enable some plugins in order to implement this rate limiting policy for this route over here. So here's Kong Manager again, and here's my route. The Kafka upstream route is up here. Then again, I click on View. I can see there's only one, the Kafka upstream plugin enabled to it. And then I'm going to click on the Add plugin. And then I'm going to choose the rate limiting plugin. And then I'm going to create a very basic rate limiting policy saying that this route is supposed to be consumed only 3 times a minute. So I click on create, and then I can see that now I got 2 plugins enabled to this route over here. And then if you go back to Insomnia and send some requests, we're going to see that this time in my response headers, I can see specific rate limiting headers telling me that I'm supposed to send only 2 more requests in this given minute. So if I keep on sending requests to the API gateway, I eventually I'm going to get this 429 error code, meaning that I have reached the rate limiting policy I have created before. So this time, and again, not just exposing the Kafka platform from our external consumers, but then again, I'm controlling the consumption, again, with very basic rate limiting. Anyone can implement other policies like, authentication based on API keys, OpenID Connect, caching policies, and so on and so forth. All right, that's all I have for today. I hope you have enjoyed it. See you next time, and I'll open for questions now. Thank you.